Physics Part 183. At the second position of resonance, 3 lambda divided by 4 is equal to L2 plus E. By subtracting these equations, we can eliminate to give lambda over 2 is equal to L2 minus L1. From the wave equation, the speed of the sound is given by C is equal to Fa. Thus, C is equal to 2F into L2 minus L1. Figure illustrates a method of measuring the speed of sound using stationary waves in free air. Rather than in a resonance tube, the signal generator and loudspeaker produce a note of known frequency F. The reflector is moved slowly back and forth until the trace on the oscilloscope has a minimum amplitude. When this happens, a stationary wave has been set up with one of its nodes in the same position as the microphone. The microphone is now moved along the line between the loudspeaker and the reflector. The amplitude of the trace on the oscilloscope will increase to a maximum and then decrease to a minimum. The microphone has been moved from one node through an empty node to the next node. The distance d between these positions is measured. We know that the distance between nodes is lambda by 2. The speed of the sound can then be calculated using C is equal to F into lambda, giving C which is equal to 2FD. We've got a few examples for you. Number 1, a string 75 centimeter long is fixed at one end and the other end is moved up and down with the frequency of 15 Hz. This frequency gives a stationary wave pattern with 3 complete loops on the string. Calculate the speed of the progressive waves which have interfered to produce the stationary wave. The 3 loop patterns corresponds to the situation where the length L of the string is 3 lambda by 2. The wavelength is lambda is thus 2 into 0.75 over 3, which is equal to 0.50 meter. The frequency of the wave is 15 Hz, so by the wave equation C is equal to F lambda is equal to 15 into 0.50 is equal to 7.5 ms. Number 2. Find the fundamental frequency in the first 2 overtones for an organ pipe which is 0.17 meter long and close to one end. The speed of the sound in air is 340 meter per second. The frequencies of the fundamental and the first 2 overtones of tube of length L closed at one end are C over 4L, 3C over 4L, and 5C over 4L. The figure shows 8.43 minus 8.45. The frequencies are thus 340 divided by 4 into 0.17, which is equal to 500 Hz. 3 into 340 divided by 4 into 0.17 is equal to 1500 Hz. And 5 into 340 divided by 4 into 0.17, which is equal to 2500 Hz. So we have got 2 examples here and we've provided you the solutions of those questions held in the section as well. We'll have more in the next video as we move along with it.